Okay, so let's take a look at the old Chapter 1 test, numbers 1 and 2. These are about the 12 basic functions, except really you only have to learn 10 for this test, and it turns out on this test in particular, I only asked about these 5. So it says make a quick sketch of the following 5 functions, so we'll do that. And these, you just kind of have to know them. So let's see, x cubed does this sort of thing. Well, let me use a different color. So x cubed does this. Root x starts at 0, 0 and goes up kind of like that. 1 over x has an asymptote at x equals 0, so it never crosses the y-axis and instead does this sort of thing. Ln of x also has a horizontal asymptote at 0, but it comes up like this, and then there's nothing on this side of the graph. And cos x starts at 1 and then does that wave thing like that. And I'll draw the arrows on the ends to indicate they keep going. And then in number 2, you're supposed to select everything from problem 1 that the following statements are true for. So of the 5 functions up above, which ones are odd? Remember, odd means symmetry around the origin. Or if you plug a negative x, you get the negative of the original function. Or you could think of it as symmetry by rotating around 180 degrees, you get the same exact graph back. So the ones that this is true for is going to be the graph in A and the graph in C. Those are the ones where if you plug in x, you get the negative of whatever you started with. Sorry, if you plug in negative x, I don't remember what I just said. If you plug in negative x, you should get negative whatever the function actually is. Horizontal asymptotes. So the ones that have a horizontal asymptote means they approach a specific value way out at infinity and negative infinity. The only one that does that is C. That's it. Nothing else actually has a horizontal asymptote. Part C here says limit as f of x, limit as x goes to 0 from the right of f of x is negative infinity. So as x as we look at values of x that are positive, but just around 0, the y values have to go to negative infinity. So you might think it's this graph right here, but as x goes to 0 from the right, this goes to positive infinity. This one goes to negative infinity. So really the only choice here is D for part C. Unbounded means either not bounded above or not bounded below or both. And so this one is choice A. That's definitely not bounded. B keeps increasing without any boundary. C definitely is unbounded. It goes both up and way down. D, same thing. That both goes up to positive infinity and down to negative infinity. E is the only one that's bounded both above and below. And then in part E, it says it's increasing if you start at 0 and just keep going. So the function has to keep going upwards as you move to the right from 0. So in this case, A works. B also works. C, it's decreasing from 0 all the way on. D, it's increasing from 0 and continuing. And then that's it. E just keeps bouncing up and down. So it's increasing, then decreasing, then increasing, then decreasing. So we would just say A, B, and D. Okay, hope that helps.